now. So Joseph,
All right.
go for it.
Hello, everyone. Sorry, I cannot see you since my computer blocks everything, every movement once I start the presentation. I'm Joseph El Haj. I come from Egypt and I've been working with Concept for 3 years now, almost. Like in March, it will be 3 years. And today I would like to present a topic called Object Calisthenics um, and what its effect in the IoT world. So let me start by giving you the problem itself in the IoT. The IoT Internet of Things, we have multiple levels. We start with the personal level. Right now, with how big it is, with starting from the Philip Hughes to Raspberry Pis and all of the different sensors, all of the different actuators, a lot of people are interested, even though that they don't have so much background in software engineering. But IoT is bringing everybody in. It affects us in our daily life, whether directly with those examples or indirectly through different ways like Uber, for example, which is really based on IoT, infrastructures, or everything else. When it comes to the professional levels, projects have become smaller and smaller, bringing a little bit of modules. Companies started learning since with IoT, you usually build the modular object and so on. Usually, you have distributed platforms that it can handle in the cloud, that can handle a lot of different devices. Because when we're talking about IoTs, we're talking about a huge distributed system with millions of devices. And at the same time, usually, we have in one big project a lot of different contractors, consultants, that are working on different packages within the big project. So what should we consider usually? We should consider always how modular it is, how it's working by itself. Um, since we're talking about cross-company operations, your code should be self-explanatory and it's usually easy to export or import the code, which in different words or in the GitLab word, it's easy to push and pull the code. And once you do that, you can understand it. Right now, we have a lot of different code that is free for all to see. And usually people keep following those very easy tutorial in order to enter into IoT, but then they get confused and they need to read millions of documentation. And that's where the object calisthenics come. What does calisthenics mean? It just means gymnastics exercises that help a person reach a certain finesse, fitness, and grace in their movement, in how they act, in how they play the game. Object calisthenics are the equivalent in programming. They are basically 9 exercises that Jeff Bay proposed in one of his books, and it is proposed in order to improve the code. Those are basically just exercises that everyone should do on their own code in order to reach this fitness, grace, and finesse in your coding. Those are just, we can have it a little bit as a guideline, but they are definitely not rules. As I said, they are just a little bit of a push in order to look back at our code, improve it, make sure that it's self-explanatory, and make sure that people don't need to read hundreds of lines of documentation in order to understand small packages. In this presentation, I will discuss the 9 exercises and I will say what personally I started implementing since I learned about this and how it's affecting me. Any questions until now?
Maybe just for me, just to sort of get the direction. So this has a real specific, shall we say, advantage. Well, if you do this, this has an advantage for IoT projects, right?
Yes.
Okay.
Yes.
So maybe just
So
for my benefit, just to expand on that, just a
it's
sentence.
not. So those rules help you become a better, in general, become a better engineer, software engineer, and
Mm-hmm.
especially, but they're only very small. Like some of those rules would actually be very well, very coupled with some of the IoT concepts.
Okay.
But I would like to go through all of the 9, and everyone
Mm.
should decide for themselves what will fit them in their environment.
Brilliant.
Um,
Okay.
because those exercises, not rules, exercises are very polarizing, and not everybody accepts that. Um, and that's why going through them, understanding them one by one, and then explaining from my experience what benefited me in my projects would help other people relate and then make their own opinion.
Okay. No, brilliant. That's exactly what I wanted to hear. Thanks.
All right. So first one, we're starting a little bit. It's a little bit technical, so if I get too technical, please let me know, and I will try to get a little bit on a business side of level. So the first one says that there should only be one level of indentation per method, which means that we should not do a nested loop. And here I put in a small example where in, let's say, for something like Uber in a ride hailing project that happens quite often, we're trying to find broken vehicles, broken cars in multitude of fleets. All right, so usually what happens, what a straightforward programmer would do, would just go through all fleets in one fleet list, and then would go through every vehicle in one fleet, and then check every vehicle whether it's broken or not, and then add it to the list of broken vehicles or cars. So it's quite straightforward. Of course, in real life, it doesn't happen like this, but you do in steps 0, 1, 2, and 3, you do a lot of calculation, you have a lot of code, which means that you have a lot of documentations also in line, and then this 4 lines become more like 50 lines in order to do one specific thing. And when we follow this exercise and we try to improve our way, we try to flatten every single line from the 0, 1, 2, 3 here, and put them in their own method. This way, we encapsulate every single method with its own meaning, what it's doing exactly. This follows a very strong principle in programming in general, and definitely in IoT, which is called single responsibility. And that's saying that everything should have only one responsibility. And in this case, we divided them into 3 different methods, and every method have one specific responsibility. So the first one from the top is responsible to find whether a vehicle is broken or not. Of course, this is a very simple example, but sometimes in order to find whether a vehicle is broken or not, you have a lot of calculation to do. And then the second one would have, which is trying only to filter vehicles in one fleet. Again, so it's not as simple as just going through them. Most of the time, we have a lot of conditions of filtering such things. And finally, the last one is basically to try to find the proper fleet that we're trying to match or to find broken vehicles in. And again, simple example, usually it's not that simple, and this is already 10 lines and it's already complicated. This, from my personal experience, happens a lot where because in my projects you have one file that is doing a lot of things, and you don't really care whether it's like one big files or very small, or with one method or very small methods. But once you start moving, you can use this in different other files. You can modularize this into just one package and use the different methods in different places. Yes, so that's the first thing, and I think it works very well for us. The other one, the other exercise is to not use the else keyword. What does that mean? It means that every method should not really have the last else keyword. As you can see, we have the if, else if, and then else. In this case, someone from outside that is reviewing your code or wanting to use your package in his own project, their own projects, would look at this and then will not understand what this function will do. It happens a lot in IoT that you're only exporting interfaces, which means that you're only exporting the vehicle broken signature. Uh, I hope that everybody understands what that means. But in general, what it would mean is that someone from outside would never understand what this function would do, especially since it does a lot of things. And in the book, they proposed multiple things. I will just focus on one, which is having an optimistic way of looking into the method, meaning that I'm just expecting everything good to happen in the beginning, and then in the end of the method, I will do my extra work. So let me go back and explain a little bit more. In this case, we have else if, and then else. Let's start with the if. The first one, we're checking if the vehicle is working, which means that the motor capacity is bigger than 50% and the brake capacity is better than 20. Those are just random number. We're checking if the vehicle has a brake problem, with also like if it's less than 20. We're checking if there's a problem with the motor capacity, and then finally we're checking just the car in general. In this case, we don't really have a specific reason why this method, whether it's checking the vehicle broken or not, whether it's checking whether it's working, and so on. It's very confusing. So what they propose is that having the everything returning early, which means that having the working vehicle return early, which means that we're just expecting, not expecting it to be working. We're saying we're not expecting the brake to be broken. We're not expecting the motor to be broken. We're expecting that we're gonna check the vehicle every single time. And this where you can see at the end. Um, and this is how you can, with the same exact method, of course, it's not usually that easy, but just for explanation, now we know that the vehicle broken function is just basically checking the vehicle. And with this way, its interface, the one that we exported, can easily be explaining this point. This is usually not very useful in most of the things, but in some very specific cases, this exercise can be useful. This is for me one of the most controversial and useful personally for me. And it says to wrap all primitives and strings. This means that we don't expect something like latitude and longitude, the location of a car, to be just numbers. We don't expect something like a first name or the VIN of a car to be just a string. And definitely the temperature or the hour is not just an integer, is still not a number. Let me give you an example. If we say something like integer temperature, so number, and I wanted to have it named temperature. All right, and then I say 5. Someone from outside will never understand what this device is sending me, what is actually being sent, because the number doesn't really represent anything, it just represents a digit. And if I say float, lat, and long, and vin, this makes more sense, I guess, but at the end, those are objects. Those have a lot of different meanings. They are not just a VIN is not just like a description. It's not just a string that you're reading. If you replace it, if you replace this VIN, for example, with just a text from your favorite book, it doesn't mean anything. It's incorrect. It's logically incorrect. And that's why a VIN is not a string. It's not just letters. It's actually something else. And this is very important, is to encapsulate this within its own object. So now we have something like a VIN object, and then we have a location object that has a lat and lon, and then we have a vehicle object that have those both. For something like a temperature, if I send 5 back, 10, maybe it's Celsius, maybe it's Fahrenheit, um, nobody knows what it is. Maybe it's minus, negative, positive. It's still unsure. So if we wrap it and then we have, for example, it's a unit and then everything else, then we can understand what this is. Um, Is it okay so far? Any questions?
Makes sense. Don't worry. It's actually, yeah, it's easy to follow.
All right. So with the same idea, this is usually very fun. First class collections, and the name of the exercise is not really defining what it actually is, but just like the primitives, we also want to have every single list or collection has its own class. Um, so in this example, we have something like um, a concept reply, our company, and we have a list of vehicles and we have a list of employees. And then those are just new lists, and then we want to add a new vehicle to the company, but then we put some conditions into it, which means that we want to have to check the vehicle whether it's working or not. We want to check whether the employee will be able to drive this vehicle, and then finally we are allowed to add this vehicle. Quite easy. True, but what if we have a different um, class that's called, and we divide this concept into two different business units, and both of them are in different classes, and then you will have the same code twice with different ideas, with different methods, and then this add new vehicle will be different in both classes. And that's why it's better, or the proposal it's that sometimes it's better to actually have everything wrapped within an object that is called concept vehicle list, for example. And then we have concept vehicles is within it, and then we have the new method, which is add new vehicle, which will always be used once you have concept vehicle list. All right, and then we have also concept, the object, and then we have the two objects inside of them instead of the two lists. Let me give you also another example. Uh, what if we have, what if we want to, what in this case, we can add a different function that will just add the same vehicle in the same class, and it will mean different things. That's one thing. The other thing is that what if I write list vehicle and then concept two vehicles in the same class? Those will have different implications because they will not work the same. Because now in the last line with concept vehicles, you will always add in one of them differently than you will add in the other. But if I add here another concept vehicle list, concept vehicles 2, let's say, it will always be the same way where I add new vehicles. And this is just a small idea of why this is very important. Again, let's talk about IoT. If I have list of devices and then different consumers, different customers are using my package, my SDK, my development kit, um, and then they are both implementing their own lists, their own logic outside of my package, this can create a lot of problems. It's always better to have no lists available and to have all the lists as objects and only create interfaces for those lists and the functions within them. This way, they cannot really, every single customer will work with the same way, and it will definitely be easier to debug, to monitor, to understand why it's problematic. And definitely in this case, you will have as a developer the power to know all the functions and what they do. All right, so let's move on. This is controversial, and most of the time, to be honest, in my personal opinion, it doesn't work, or I was not able to apply it in most of the cases that I have. This basically says that no class should have more than two instances of variables. For example, in this case, we have a vehicle with the lat long accuracy and a VIN. What this say is that this doesn't work, but we have to have something like this, where you have a location, You have geodata with location and accuracy. You have the VIN object, and finally you have the vehicle with both of them. This promotes a really high level of cohesion, and it encapsulates all of the different um, primitives. It encapsulates every logical idea or business logical idea within a programmatical idea. Of course, this wouldn't work, for example, if we have in the location, we also have something like height. Um, this wouldn't work if, for example, we have a lot of different parameters in a vehicle that needs to be together. For example, just one sensor sends a lot of different things at the same time, and we have to accept them all. Um, and this is where it's really apparent that those are really exercises. They're not 100% guidelines, and they are definitely not rules, because this would work in this example, like the rule would work in this example, but it will not work in most of the examples, in most of the cases. But if a developer would actually put effort into understanding this, into understanding why it is, trying to implement it, they will understand their code better, which means that the value of the code as well as the quality of it will increase highly. Another thing is the one dot per line, meaning that we shouldn't really chain methods or chain calls in general. So something like this, where we have a fleet manager, and then within that we have only one vehicle, and then we have within this vehicle geodata, and then the location, and then the lat. Having something like calling this dot that dot that dot that and then setting it to new things is not really the most optimal way. Um, because first of all, people will have to understand every single structure, and they will have to go through all of the different interfaces in order to understand what this does. Of course, again, this is a very like simple example that I'm just putting for you to follow, but in real life, this line would be bigger. All of those will be actually functions instead of just calling the variables, and this line would be like 150 characters. Um, Following the rule of primitives as well as the lists, with combination of this one, we can actually do a little bit of a small switch where we have the geodata changing the location within itself. We have the vehicle updating the geolocation, and finally the fleet manager updating the vehicle or calling the update geodata within a vehicle. And this way, once a person goes to this manager, fleet manager, and then they see, and then they understand vehicle update geodata. That's what I want to do. And they don't really need to understand what this does. They don't really need to understand and go through every single step in order to see what it means. They just can understand it as it is. Um, is this still? Are you able to follow? Any questions?
I can follow, yeah. I mean, I can see why it's controversial, at least. Because this
Yes.
is, especially like for like something like functional programming, like Scala, I could
Yes.
see
So
this might cause fights. Yep.
this is something that I may have missed to say, which
Hmm.
is basically all functional programming and all lambdas are not included into this rule.
Oh, okay. Yep.
All SQL code, everything where you are forced to chain in order to make sense out of it,
Hmm.
this will never be applied to it.
Okay. Okay. Brilliant.
So yes, again, still controversial even with this extra information, but definitely y- it's really nice when someone just when a outside consultant or internal gives you directly a function that you can read within 1 second and understand what it does. It makes everything easier in my personal life, at least for now. So
That
yes,
helps. That helps.
yeah, yeah, definitely. uh,
Okay.
all right. No getters and setters properties.
Ooh. Yeah. Okay.
Yes. Um, just let me give you a disclaimer since I forgot to give you the Scala, the functional disclaimer before. Um, in this case, we don't mean that you cannot really set an object outside of itself. We just mean that whenever you're getting and setting, you should not make logical decisions based on it. So let me go to the previous example. In this example, we still have the location, the geodata, and in the geodata, we have the change location, which we had it before. And this is obviously a setter. Like we have a get, which is get lat, and then we have a setter, which is equal so and so. But then we have the calculate location based on velocity. So based on the velocity, and hopefully this velocity have also the direction with it, like so it's a vector, and then we know how much time it is, and then we want to calculate the new location. And then we have the exact same code, which is lat dot location dot lat, and then equals to the new one, and so on. Can anyone guess why? I probably just said, but do you know why it makes sense to actually move where the first one would make sense to be there, but the second one would be a problem? Anyone can guess? I said half of it.
Yeah,
Half of
no,
it.
maybe it's too late for me. I don't know. I missed it.
Yeah. So, okay. So basically, in this case, we are, first of all, we're making a decision outside of the location. And this I said in the first and second rules, it creates problems, especially in something like IoT, where you have a lot of different files that are using the same object, that are using the same sensors, that are actually decoupled completely. You're making decisions outside of your own class, which indeed
Mm,
will have something. If we have geodata 2, and then we have a calculate location, and this calculate location has a different way of calculating the location, then you have two different points of truth, right? So if me personally, I calculate the location based on velocity differently than someone else, or in an easier way, measuring the distance between two locations with lat and long, there are maybe like one or two functions, but most of them use different constants. So imagine in this case something where you're working with 1,000 device, and then depending on who receives your data, they make different assumptions, different calculations, and then they assume different things. Imagine how dangerous can this be with something like an Uber or vehicles, where you're actually calculating distance differently depending on different classes. And this is why it's actually important and of having getters and setters, or in general properties, manipulation and logic, all within the same class, where you export it to everybody. So in this case, if I'm the person responsible for the location and someone else, or like I'm giving the location to different customers, I should create the calculate location within it, so that everybody will calculate location the same. Everybody that uses, let's say the geodata is external to the company, everybody that implements this geodata will implement it the same, which is basically location dot calculate new location with the velocity, and they will always get the same value. And this will minimize the problems extremely. And this is why it's a little bit tricky of having like the name no getters and setters properties and so on. But in fact, how you can apply it is very critical, especially as I said, to something that serves thousands of points. And with thousands of points, you have thousands of points of failures. So if only two different calculations happen, you're already having, let's say, 500 different than the other 500. Yeah.
okay, yeah, makes sense. Makes sense.
Moving on. Don't abbreviate. Abbreviation is the enemy. If you're abbreviating, you're doing something wrong. First of all, if you're following all of the different exercises, then most of the time you will not need to abbreviate, because everything is very simple, very small. Um, you should never, or let's not say never, but it doesn't make sense to abbreviate if everything is just small and concise and the scope is very clear. Because you have two reasons. If we say that the class is just too long, we're using the same method multiple times or the same parameter multiple of times, then maybe we're not really, we need to refactor our code. Maybe because we're using it too much time, we can actually merge some of those times into different functions where we can reuse this one. Another thing is that um, if we say that the name is too long because we have a lot of different things, something like temperature now, temperature later, temperature in the future, and so on, if it's all in the same class, then maybe we're violating the single responsibility principle, meaning that maybe this class is just too big and it should be divided into multiple classes handling different types of temperature in this case, or things in this direction, basically. If the name is too long, um, then maybe the class is just too big. And if you're using the name multiple times, then maybe there are a lot of duplication in the code where you can actually merge them into one function. And this is why this exercise, again, is just in general very helpful to understand, not really IoT relevant. Finally, this is, I think, the most important thing for IoT, which is keeping all entities small. Uh, most of the devices are very small. Most of the devices don't have that much memory. Of course, it's better than 5 years ago, let's say 10 years ago, um, in different work, different programming sections. Um, but still, a lot of devices are just very small. They are sensors, they are actuators that just can accept little of data. So why making it too big, the entities? In general, all classes should be from 50 to 150 lines. More than this, it means that the class just have way more responsibility than it should, and maybe you should divide it into 2 or 3 classes. And then if the package is too big than 10 files, first of all, most probably it's too much interdependent and you can divide them. Secondly, it will not work for all devices, right? Most of the devices may be able, but from time to time you will have very small devices with small memories where you cannot really apply this. Of course, in the normal life where you have Raspberry Pi that is as powerful as a computer was 5 years ago, this will not really be the most optimal way to go, but definitely it's the better way to go to improve ourselves. So let me recap a little bit and open the discussions. Those are the 9 again exercises, not rules. First one is not to have a lot of indentation, so divide the methods where everyone is responsible for a functionality. Not use the else word, which is not really useful in most cases. Wrap all primitive and strings, very useful in my opinion. Again, first class collections, this is where the lists, collections, arrays should be wrapped also within their own classes. No classes with more than 2 instances. Again, this doesn't work in most of the cases, but definitely a good exercise to follow in order to try to minimize and go with not rule, sorry, exercise number 9, to keep everything small. So maybe if we push the instances a little bit to the limit, we can actually keep the entity small. Number 6 is to not have chain methods. Number 7, no logic outside of the class where the logic should be. And finally, number 8, not to abbreviate, because if you're abbreviating, you're hurting the other people that are looking at your code, especially externals that cannot really access your documentation. And moving on to number 9 again, to keep everything short and concise. Um, this was based on the work of Jeff Bay, as I said in the beginning, from the ThoughtWorks analogy. That's the book, anthology. Sorry, that's the book. And William Durand is a programmer that also made it very short in his blog to explain it very simply in case someone else doesn't have the time to go through the book or through the exercises, but want just to have, again, a short introduction. Thank you all for listening. And yeah, any questions?
And don't be shy. I know it's a bit weird talking on Teams, but please feel like you want to know more. Now's the time to ask. I do have a question, though. Very, should we say, twee question. It's not very technical, though.
Yeah.
I'll shoot. Yeah, I'll shoot. Which one of those do you hate the most?
Hate the most?
Because you must have one that you dislike. Come on.
Depending. Hating because I don't.
Okay, hate's a strong word. Hate's a strong word.
Okay, no, but whether I hate it because it's really hard to do or hate it because I really don't understand where it's used. Because I will just give you both examples. So for me, the hardest one is basically the no getters and setters, because most of the time it's way easier to just create a list and do like manipulation there. But or at least I am so ingrained in just creating lists of things wherever I need them, and then because at the end I'm just making a list, I'm doing nothing, but then what happens is that within 2 months, oops, you already have a lot of code, a lot of logic, and then you're using this logic differently in a different class because you have the list different, and then it goes big. And that's why this one I hate it, because for me it's the most important one. What I, let's say, hate because I really don't understand how it would work most of the time is the number 2, not use the else keyword.
Yeah.
This is for me the most
slightly.
Yes, this is the most confusing one, at least.
I mean, I can see why, but at the same time, yeah, should we say unrealistic in some cases?
Yes, definitely. And in some languages,
some languages
you have to use the else also, as one of our colleagues pointed out previously in the same.
Yeah, and also, for example, if you do anything like recursion or anything like this, again, go to the functional world, you need an else keyword.
Yes.
Well, depending. Okay then. Unless there's any other quick questions, I will probably hand it over to Oliver, who will talk about something totally different, but also I think very interesting. I think it's actually more of a, should we say, a future view on things. There's a bit of an overlap with what I did back in the ancient old days when I was doing a bit of embedded stuff in my bachelor's degree. And although what they do now is much more advanced, so I don't know. Oliver, do you want to try and share your screen and we can just kick it off?
Can you see my screen now?
Yeah, I can.
But with my dog.
But with your duck. But it's okay. It's a nice duck.
All right. If everybody can see it now, I talked about virtualization as foundation of the cloud, and how that relates to IoT is that for most people and also for most companies, I would assume that the cloud is enabling them to do IoT in the first place, because for most of them, it would not be possible to. Did you get your cat?
Yes, sorry, it was irritating me.
It would not be possible to provide the infrastructure needed to do IoT on a big scale. So for many people, the cloud is an enabler for IoT, for many companies too. And therefore, founding the cloud virtualization also is the foundation of IoT in many cases. And when we talk about IoT and the cloud, I guess most people will recognize one of the icons on the left. Amazon already gives itself away by writing its name in the logo. The others, Google Cloud, Azure, and Ali Cloud on the bottom left. And if you have worked with any of these cloud platforms, it's quite likely you used EC2 or the Google Compute platform, ECS for containers, or Lambda and Azure Functions for different classes of virtualization, where EC2 and Cloud Compute are for full virtual machines, ECS and its competitors and other platforms for containerization, and Lambda and Azure Functions for very fine granular virtual environments for running single functions. And if you don't happen to develop web applications, but are very far on the edge of the network and more into hardware development, you might still have run into IoT Edge or Greengrass with AWS, which enable you to run Edge and IoT device applications in virtual environments very close to the edge. And there's many economic factors that that cause the emergence of the cloud and all the services mentioned here. But there's one singular technological factor that influences them all, and that's virtualization. And because virtualization is the base of so many services in the cloud, I think understanding the underlying technologies will enable most people to utilize these services to the max. So the question is, what is virtualization exactly? And to define it, I copied this definition from Wikipedia, which says that in computing, virtualization refers to the act of creating a virtual version of something, including virtual computer hardware platforms, storage devices, and computer network resources, where I believe that storage devices and network resources probably part of a computer hardware platform. So virtualization does that. And to understand why this is important for running applications and IoT applications specifically, first we should step back a little and I want to talk about how applications are run traditionally in a native environment. Generally, you will have every application require a certain set of resources. Most likely, or not most likely, mandatory are a processor and a memory, and quite likely are also persistent storage and network devices for an application to run. There's other devices too, which I leave out here. For example, human interface devices like a mouse, keyboard, or GPUs for graphic processing or neural networks, or all kinds of other devices that might interact, but they're not too important for running servers or web applications and also IoT applications. So in the most simple setup, we'll have a single process that accesses these resources. And in a very simple case, it accesses these resources directly without any detour, and it will just write to registers from memory. It will directly be controlled by the CPU using interrupts, and there's no abstraction layer in between. And if we are at that level, you can think of something like a punch card mainframe or a microcontroller that runs a specific defined routine, and that doesn't diverge and it doesn't multiprocess. This kind of a setup will be our baseline to compare all other methods of executing applications, and the dimensions that we will compare these different platforms for running applications are scalability and isolation. And on both scales, we put the single process machine in the very bottom left, meaning that it's the lowest score that it can get. The reason for that is because scaling will be very hard with this model, because you would basically have to buy another computer and run it in parallel. For isolation, you could basically see it in both ways. Because you run only a single process, it's perfectly isolated. But what we want to assume here is that we see the isolation of different functional components of an application. And in that case, the single process has to house all the functionality, and therefore the functionality cannot be isolated. We can abstract and introduce a first layer of abstraction by introducing an operating system to our computer that will be a mediate for the process to talk to the hardware, for example, through virtual memory pages or virtual network devices that translate to the actual physical device. But by only doing that, we will still not progress on our comparison chart and still stay in the bottom left. If we want to get better in the regards of isolation and scalability, we will have to go to multi-user and multi-process operating systems, which give us the illusion that we would run multiple processes at the same time and they don't interfere with each other. In these kind of systems, the process is defined by its process ID, a group and user ID, which are linked to the user that runs the process, or the process that's also a user that launched the process. And in addition, with the priority the process gets, and we can mediate the access of different processes in the same system to the resources and run many of them seemingly at the same time, while actually they are doing a time sharing model. And this sounds already quite good for us when it comes to running multiple stuff in the same environment. But what you actually should think of is something like this, an old mainframe with many connected terminals. So basically 80s. The question is still, if we have the multi-user, multi-process OS, we could basically run everything we want on the same machine. We could have a web server with a database, an email server, and a file server on the same machine, and they wouldn't interfere with each other. The PID will make it memory only accessible to the same application. The user ID and group ID will define file access, and the priority will give the scheduler an idea of how to prioritize apps. So we could assume that we already have a very scalable and very well isolated system where the processes can run at the same time, not reach each other's files, be prioritized in CPU time and memory access. But the sad truth is that we actually don't have this nice system. What's much more likely is that we end up with something like this. We have 4 different computers or servers, each running one application because they have different requirements, like our database being, for example, MySQL, Microsoft SQL server running on a Windows server, and then we have a file server which needs to be isolated for some compliance reason. The email also because GDPR requires it, and the web server runs on Linux, and therefore they all can share the same machine. And this leads to a sad situation where we have to buy way more hardware than we would actually require performance-wise, and we get poor utilization of our resources because we run a lot of them. So even with a multi-operating system, the reality is mostly that we end up in the bottom left, still quite far, rather than on the top right. And here I also introduced different targets in this as plane. We have function as a service in the top left, in the top. This is the area where we have highly granular parallel systems, and multi-tenancy on the right, where we can run multiple isolated instances on the same hardware. The example there would be, for example, the email server that's GDPR requires us to store the data separate from other applications. And yeah, the highly granular services, stuff like Lambda on AWS, where you have to run a lot of functions isolated from each other without messing with each other. And to get into this area, on top of the multi-user operating systems, we have to have a new technology, and this technology is virtual environments. And virtual environments enable us in different ways to move on from this setup where we have poorly utilized hardware to a setup that's more efficient and effective. And the first one, which is older, is hardware virtualization. And in hardware virtualization, we simulate the virtual machines, which run an application each and are completely isolated from the perspective of the application, while they still run on the same physical hardware. This is done by a hypervisor, which is the software that simulates these virtual devices. It depends, there's 2 different hardwares. I'm going to go a little more into detail later, but the effect is that if we have a virtual machines running inside the physical machine, we can get our utilization up by taking components with low utilization. I go back. Like the email server or the file server, and putting them in the same hardware, and then they share the hardware and utilize it better. The database we left in a single machine because it already had a high utilization. And this puts us on a scalability-wise slightly up, but on an isolation level, it already enables us multi-tenant environments where we can have multiple customers or multiple parties sharing the same hardware without them interfering with each other and their data being safely isolated. Yes, the technology that enables hardware virtualization is either hardware virtualization or power virtualization. In hardware virtualization, we simulate physical hardware, so the virtual machine doesn't know it's virtualized, or we provide virtual hardware, which requires the virtual machine to have dedicated support for virtualization. In both cases, it's a hypervisor running the virtual machines and providing the devices. And popular implementations for that are mostly KVM and Zen. Zen is being phased out more and more, while KVM is becoming more popular. And on the proprietary side, there's Hyper-V, or also some Microsoft offerings, and VirtualBox is also available for desktop virtualization, where you run the hypervisor inside your operating system on your desktop to run multiple graphical user interfaces at the same time. Another distinction is between bare metal on top of OS. I said VirtualBox is for only desktop. That's on top of the operating system. KVM and Zen are bare metal, and they run directly on the hardware without requiring operating system of themselves. The problem that we have is that each virtual machine runs an operating system, and this is our bottleneck. And this explains why on the scalability side, we weren't on top yet. We were quite in the middle, or even a little below that. The solution to this bottleneck is OS-level virtualization or containerization. And in this technology, we have the virtual machine running on top of a container engine on a shared operating system as a base, meaning that every operating system uses the same kernel, every application uses the same kernel, and only has an isolated environment on top of that. This leads to a hugely reduced image size for the containers when compared to operating systems. We talk here like between 4 or 5 gigabytes to megabyte sizes. A lot less memory usage because only one kernel runs. Same for computation time. And the boot time is very fast for containers, allowing us to run services on demand quite quickly. And this brings us into the area we can provide function as a service like Lambda or Azure functions, but sadly not in the area where we can provide them for multiple tenants at the same time. And the reason for that is, as I mentioned already, in OS virtualization or containers, we run a container on top of an operating system. And the idea of a container is quite virtual. It doesn't really exist. It's not even a concept in the operating system. It relies on Linux for running containers. So if you run Docker on Windows or Mac, they run a virtual machine. And they use namespaces and control groups to provide an environment inside the operating system that seems to the application to be completely isolated. What actually happened is that namespaces reduce the file access of a container, as well as the access to other processes, and control groups access the resource usage, so you can limit processes to only access a certain CPU or only a certain amount of CPU time. Because it's quite complicated to define this, there's abstractions on top of these concepts. For example, OCI bundles, which define a container, which is a process running inside one of these virtual environments. And you can use libraries like runc to run such a bundle as a process would define namespaces and C groups. And even though it's quite easier to do that, it's still not at a level of comfort that most people want to use. So for that reason, there's abstractions on top of that, like the container daemon and Docker daemon, which then allow users to very comfortably get images from a registry and run them locally without thinking about much what they do actually. And there's alternatives, but mostly people will use Docker for that. It's basically the industry standard. But for alternatives, if you're interested, there's a nice article I linked in the presentation. And yeah, as you can see, there's a lot of them, but basically all of them based on runc in the end. So now we have containers and we have virtual machines, and virtual machines enable us to use multi-tenancy, while containers allow us to have highly granular services running at the same time without a lot of overhead that the virtual machines have. But we're still not in the, so to say, golden area on the top right, where we can provide multi-tenant environments for highly granular services like AWS Lambda. And the most obvious solution to this problem is running containers inside virtual machines, which is also exactly what AWS did in the beginning. But because people always like to do stuff and improve, there's also questions whether we can improve on this, because it seems like a hack. And there was the dream of Unikernels, which enables you to run applications directly on the hypervisor without the intermediate operating system adding bloat to your system, and without the security implications of running all of the applications in the same system with a thin layer that isolates them from each other. It's not that easy though. So instead of actually just running the application directly on the hypervisor, we still have to use some sort of an operating system. And the answer here is we have a library operating system. And together with the custom libraries that you use and your own code that you write, you take the library operating system and compile it, if your application is done, into an executable image for the hypervisor, which is then called a unikernel. And yeah, you see that here everything is fused into one unit rather than having a separately compiled operating system that offers interfaces to the application. You have one unit and all the functionality that's not used is stripped at compile time. So you'll have a very small image, very small attack interface, and also maybe the dream solution for IoT with some caveats though, because you have to be limited to the programming language of the library operating system. Okay, so unikernels are what could remove at least one of the question marks in this corner of our comparison plane. To sum things up in the end, I'm going to give a little conclusion. First, we have the topic of virtualization in general, which allows us to improve the rates of hardware utilization by consolidating servers into a single hardware rather than running multiple hardwares for different applications. It also facilitates increased security and safety because you can do that by running the applications in a different environment and they can't interfere with each other. And it allows you to bundle dependencies with applications for deployment, either as a container or as a virtual machine image, which means that you can run it on any computer without having the trouble that your application doesn't work, for example, on your customer's setup. Inside virtualization, you have virtual machines, which are very secure and offer a great level of isolation. But because they run a single operating system in each virtual machine, they generate a lot of overhead, especially for memory usage. And you have containers, which are very lightweight and fast, but don't offer the great isolation that virtual machines have. So containers might have some security implications. And then unikernels, which seem to combine the advantages of both by being very lightweight and offering great isolation. But as I slightly brushed, they require you to write your application in the same programming language that the library operating system of the unikernel is written in. And also they don't offer system calls that normal operating systems have. And therefore, they require you to develop dedicatedly for the unikernel platform. And they require a lot of in-depth knowledge of the whole thing. In addition, if anybody is still interested in unikernels, I published a paper recently, which you can download in the link, and was presented at the Census workshop of the ACM. And if you're not interested in unikernels, then you're lucky too, because my presentation is over. Of course, if you have questions, feel free to ask them.
Thanks, Oliver. That was really good, actually. I did my bachelor's. I tried to do rump kernels. They were called rump kernels back then, but that was a long time ago, before cloud and all this. But it's really interesting. It's good to see someone's actually picked up on it. Yeah, sure. I actually don't have any questions. I mean, the only thing would be, but I don't know if this is an unfair question. Would be like for someone who, like me, I spend a lot of time in the cloud, and IoT has some very, should we say, strange, but also quite challenging problems in that space. do you think this Unikernel thing would actually solve any of this, or is it just too early to say? I mean, I don't know if that is a, should we say, a decent enough question, but maybe you have a few thoughts.
Well, I think for you personally, or for most people personally, they won't notice it much. I can just stop my screen. But the infrastructure might change to adopt them, because Lambda, for example, on AWS already runs the Unikernel they call Firecracker operating system. There's definitely some application going on in using this technology, but it's under the hood most of the time. So the thing is, if you want to develop for Unikernel, you have to have a very dedicated purpose, and you're dedicated in supporting this platform. Okay.
So it's something that will help the cloud get better. So said very, very short and probably oversimplified.
There's one example that's quite interesting is the company that, or not company, it's a project called MirageOS. It's the most popular Unikernel probably. They host a website in Unikernel. So static content, it would work quite well. For security applications, maybe for everything that needs to be small and robust.
Okay. Yeah. I actually, for a personal project, I use something called Solo 5, just because I get a bit, shall we say, I wouldn't say bored of containers, but sometimes it's nice to see something else.
Yeah.
And I'd say I was quite impressed. It was nice to see something that was as good as Docker and Kubernetes, in my opinion. But yeah, definitely. Okay, guys, don't want to hog. Any other questions, or should we say observations, or I don't know? Feedback is always welcome, I guess. We're all very shy tonight, which is good. It means that the presentations were good, in my opinion. At least when I have no questions, I accept that the presentation was enough, and that was all they needed. So, great. So I just thank you all for taking the time. I know it's quite late, and I know definitely December is always a difficult month for most people, with deadlines and people rushing to get stuff done for the end of the year. All I'll say is I really hope in February it will work out. We can meet each other in Munich in person, have a bit of food, a bit of beer, and we could talk a bit easier. And yeah, I mean, any people that want to present or maybe need a job, please get in touch. I can sort you out. Okay. In that case, I will take silence as time to go and eat something and time to have another cup of tea. And I will wish you all very prematurely a very nice weekend.
Yes, thank you.
Thank
Very
you.
nice presentations. Have a nice week. Have a nice evening.
Thank you. Okay, guys, enjoy.
Bye.
Well,
Thanks for the presentations. Bye.